Hi, these are the notes for balancing a chemical reaction, and the first thing that we're going to go over before we start is what is the difference between a chemical reaction and a chemical equation. And the answer to that is that a chemical reaction occurs when reactants are converted into products, and a chemical equation is a representation of a chemical reaction using chemical symbols. So basically what that means is that the chemical reaction is the reaction itself, and the equation is just how we represent and show what happened during the reaction. So when we balance chemical reactions, we're balancing the equations that correspond to that reaction. So how do we balance a chemical reaction? So first we want to count the atoms on each side of the equation, and we want to determine the coefficients necessary to make the corresponding atoms even on both sides of the equation. And we want to remember that we can only change the coefficients. That's really important. We can't change the subscripts. And then a good hint and way to do this that's going to make it easier is don't separate polyatomic ions, because it's just easier to keep them grouped together, so then you're not going through. And you'll see this in our first example that we're going to go over. So example 1, we have ammonium, and it's best to just write it under the arrow so we can have the number of atoms on both sides, on the reactant side and the product side. So we have ammonium, phosphate, lead, and nitrate. And we want to count how many there are. So NH4, we're going to keep it grouped as the polyatomic ions here, except for lead, which is an element, so it's on its own. And so we have 3 NH4s, we have 1 phosphate, 1 lead, and then 4 nitrates on the reactant side. And on the product side, we have 3 leads, 4 phosphates, 1 ammonium, and 1 nitrate. And just don't get this confused. You can draw little parentheses around here so you know not to going to these. And so I'm going to show you how to balance them. So the easiest thing that we might want to do is that we see that there's 3 leads on this side and only 1 on this side. So we can put a 3 coefficient here. And you want to make it small just in case the number doesn't add up. So you have room to cross it off and put another one in case it doesn't work out perfectly. So let's see if that works out for us. So we put a 3 here, and then we have 3 times 4 of the nitrate, which is 12. So we're going to need, the next step is to balance these, and so we have 12 nitrates on this side, but only 1 on this side. So we can put a 12 right here to get this to be 12. But that also makes our ammonium 12. And now the only thing that we need to work on is to get the ammonium on this side equal to this side, and the phosphate on this side equal to this side. And that can be easily done by putting a little 4 right here. Since there's 1 phosphate, that's going to be 4. And then 4 times 3 is 12. Oh, not on the PB, oh my god. here. This is still 3. Don't mind that. And then everything, as you'll see, is balanced on both sides. So now we have our second example, which is a little bit easier. We have Ag, which is silver, and S, which is sulfate. And we have a silver sulfide over here, and we have a regular silver and a sulfur over here. And we're just gonna try and balance it. And so we have 2 silvers and 1 sulfide over here, sulfur over here, and then we have 1 silver and 8 sulfurs over here. So the easy thing we could probably do is to try and get the 8 to be equal. So let's just put an 8 over here to make that 8. And then as you'll see, that's going to be 16 on this side. And then there's just one of these since it's just in elemental form. So we can just put the 16 here and they're equal. And that is how you solve, you balance chemical reactions. It's pretty easy, but yeah, I hope this helped.